Hi, everyone. My name is Gordon Smith. I'm Director of Product Management for Oracle REST Data Services in the Oracle Database Group. I'm going to be giving a presentation over the next 30 minutes or so on RESTful application development in the Oracle Cloud using Oracle REST Data Services. This is the information I'm going to be covering. First, I'm going to be giving you the basics of what is Oracle REST Data Services, or ORDS. How does it work, some basic ideas behind REST, and so on. Then I'm going to spend some time talking about why use REST, why this is a good idea, why you should enable your database to be a RESTful API service. Then be going through the basic mechanisms, how to do things like auto enablement of REST services, query filters, and manual service creation. Then going to give you a demo, and then lastly give you some pointers of where to go for more information. So first, the basics. Oracle REST Data Services, or ORDS, turns your Oracle databases into RESTful API services. So today it supports relational data in the Oracle database, JSON documents in the Oracle Database 12c JSON document store, and also the Oracle NoSQL database, since it's key value store, JSON information that may be stored in there. Oracle REST Data Services, or ORDS, runs in an application server and middleware, specifically WebLogic, Glassfish, Tomcat, or Jetty are the system environments we support currently. There also is the simple standalone mode for development and testing, so you don't have to stand up a complicated app server to get started. Actually, to do all your development and all your testing can be done in a very simple environment just on your laptop. It requires database skills to do, so SQL skills are pretty much essential. You can do a lot with auto enablement to do simple things, but you pretty quickly will run into cases where having SQL knowledge, PL/SQL knowledge is very, very valuable. But the key thing is that even though you produce ORDS RESTful APIs that run in an app server, Java app server, you don't need Java programming skills. It's just SQL, PL/SQL, you're good to go. So some of the basics of REST. REST stands for a representational state transfer. Some key things about it: it has a ubiquitous client API, so it uses the internet HTTP technology. So it's exactly the same technology protocol for that. Key thing about that is it's supported by all languages, at least that we know of. So certainly all modern languages support REST, ability to support REST, and even older languages like COBOL and Fortran, I'm told, have REST interfaces available to them as well. Some key principles of REST. First, it is a resource-focused API at the server. So you're using URIs, which are a key component of URLs that you see every day on your web browser going back and forth. But that URI points to a thing. It points to a resource or an object. So something like orders, employees, products, and then there are operations on those resources. And we use the same operations that HTTP supports. So these are things like gets to do reads, posts to do inserts, puts to do updates or upserts to be specific, and deletes. There's other calls to get metadata and a few other ones, but those are the key, the fixed set of key operations that act on the resources. Another key principle of REST is that it's stateless. So it is a single call. Everything is done with a single call. There's no sessions here as you are used to with SQL. So each transaction is one call, and one companion technology or supporting technology that really makes this work is JSON. So you can use JSON documents to return results of queries and provide inputs for inserts and updates. So if you have you want to retrieve or insert a complicated object that involves rows and multiple tables, like an order, for example, you could do that with one call by supplying all the information that you need in a JSON document, or putting all the information you retrieve from the database into a JSON document to send back to the client. So let me give you some examples of what that looks like in popular languages. First, JavaScript. The key thing to look here is on the bottom. Here's the URI. So it's using HTTPS to get at a particular host. Just calling it my host here to get at ORDS or Oracle REST Data Services running on that host. Customer orders is the resource we're talking about. ORDS has a mechanism called modules and templates, which I'll be talking about a little bit later, that allows you to specify the resources. And then you can pass parameters to the operation that is being performed on that resource. So here we're doing a get on customer orders, and we have a parameter of 1001, which may be the customer ID or the order ID that is being processed by that get. And that's it. That's all you need in JavaScript to be able to submit that get query request against customer 1001 orders and get those back in a JSON document typically. And JavaScript handles JSON really well. In fact, JSON stands for JavaScript Object Notation. It kind of came right from JSON, and you're able to map the JSON document you get back very readily into an object that is in JavaScript. And all languages have very good JSON support today, as well as the ability to support REST calls. Here's what it looked like within a Java code. So again, you can see here's the URI, exactly the same thing, and we're going to be doing a get against that. Here's what it looks like in PHP. Again, the same thing. Here's the URI and the parameter, and we're going to be doing a get against that. And similar with Ruby, similar with Python and other languages. It's not a lot of lines of code. It's all pretty straightforward to do. So what does ORDS do? ORDS gets rooted the URI. So first it uses the server part of that and the ORDS to be able to root it into ORDS on the server. It then maps the resource that's specified in the URI to a module and template in ORDS. And then that invokes a handler, which in the case of the Oracle database is SQL or PL/SQL, that then goes to the database, gets processed, results are then returned, and ORDS transforms them into JSON typically, but we also support other formats like comma-separated value formats, whatever the format is, say it's JSON, we then return the JSON to the client application. So it's pretty simple, really. So why use REST? So there's a bunch of reasons. First, it's people are talking today about cloud native. If anything's cloud native, that's REST. And so it can again be used by anything to connect to anything else. If you have property security authorization to get to something, you can get to it without having to install any client driver for Java or whatever the language is. Language is native, built-in support for REST, for JSON. You don't need to install a client driver. You don't need to install special networking to be able to get at anything. Everything is good to go from instantly. If you have the security authorization to be able to get to something, you can get to something right away. So that allows you, talking about the Oracle Database Cloud services, you can use REST API with all of them. This includes the schema service, the database service, the Exadata database service on the Oracle Database Cloud. You can get to that from any of the Oracle Cloud software as a service or application development environments, for example, Java or Node.js. You can get to using REST to Oracle databases on the cloud. You can also do it from on-premise as well. So if you have an app server or say a .NET or whatever technology you're using, your applications can get to Oracle databases into the cloud, again without installing any drivers, without installing any special networking. You can also get at it from browsers using languages like JavaScript and also native mobile for Android and iOS devices. They all support REST. They all support JSON, and you can get to through the REST API into the Oracle databases on the Oracle Oracle Cloud. You can also get to Oracle databases and the Oracle Cloud from other clouds. So Amazon Web Services, for example, Microsoft Azure, they all support, again, REST and JSON. So you're good to go to be able to access this anything. Another key place where REST really fits in fact, it's not just a nice thing, it's really pretty much a necessity. If you have any thought of moving to the new Microsoft architectures that a lot of people are looking at and many Oracle leaders are actively deploying today, REST really is an essential component to that. So microservices takes you from developing single monolithic applications to many smaller, more modular microservices. Instead of using a waterfall deployment of entire apps that just come out every many months separating them or maybe years separating the releases, you have agile development techniques for each microservice. You have much more incremental development, much more rapid rate of releases. Instead of having one technology stack for your entire application, you now have a choice of technologies for each microservice. So you can instead of writing everything in Java, say, or writing everything in it for .NET applications going against just one database, say SQL Server or Oracle, you can pick and choose what you want for each microservice. So, and also another key thing, instead of having one database for the entire app, each microservice has its own data store. So for many microservices, you want relational data on the Oracle databases, obviously widely applicable to many processing problems, but you may want to store some things as JSON documents for some microservices. You may want to use Oracle NoSQL database or other database technologies. The full range of rich set that's available today, all of that is available to you because you're using REST, you're using JSON to be able to bring these together and make them function all as one system. So in a monolith environment, you have in-process calls for things to communicate, because again, it's one big application. Use SOAP to be able to get at things externally, but with microservices, REST is what you use to be able to connect anything to anything else. Async messaging also has an important role to play in this, but REST really is key. If you want to move to microservices, REST is the pathway that you need to follow. Still more reasons to use REST. Faster and easier access to data for developers. So your REST developers produce the RESTful APIs to access your databases. But then your application developers just write to the REST APIs. So the intricacies of database access are removed from the applications. Application developers write to RESTful APIs, which is something that is widely accepted, widely understood, widely done today. And we're told by customers that it's easier to hire developers when strong database skills are not required. So you have a small number of REST developers with strong database skills to be able to produce the REST API, but the bulk of your application developers just write to the API, keeps things simple, keeps the complexity of database access out of the main application code. Another nice thing about REST is that it's stateless. There's no sessions involved in it. This can keep things simple. Same reason that stateless kept the internet simple and scalable and reliable. Stateless does the same thing with REST. One particular advantage of being stateless is that you have fewer network round trips for performance. So performance really is the dominant things for database access performance is the number of message exchanges you incur. With REST, it's all just one message exchange, everything done with a single call, using JSON to transfer data into the database or retrieve data from the database. So you can have just one call to enter an order or retrieve an order that might span half a dozen different tables and may require half a dozen individual SQL calls. It is one call from your application to be able to get the full object or be able to insert the full object or do an update against the full object. It's also secure. ORDS runs in app servers, So the full protections of WebLogic and other app servers that ORDS runs in are there to protect the RESTful API. There's no direct SQL access from your applications. Again, application developers write to the RESTful API. They don't have the ability to write arbitrary SQL to go against the database. They're constrained by the API that your REST application developers develop. REST also, or ORDS also supports OAuth 2, which is a REST security standard that was jointly developed and is being used by vendors like Google and Facebook and Amazon and Microsoft and, of course, Oracle. So we support that as well. If you'd like to get more information about the reasons for using REST, I'd like to recommend a blog post that I put out called Why Turn Your Oracle Databases into RESTful Services. If you Google that, Why Turn Your Oracle Databases into RESTful Services, you should get a hit and be able to take a look at that. The next thing I'm going to cover is talk about the actual mechanisms of REST. We're talking about 3 features: auto enablement first, then query filters, and then how to do manually set up services using ORDS. These first 2, auto enablement and query filters, I'm going to go over just really briefly. I'm going to be giving a demo following this section that goes into the exact mechanics of how to do each screen, each mouse click, and so on. Auto enablement is great because it allows you to very easily, with just a couple mouse clicks, to set up basic RESTful services for individual tables. So it does all the basic CRUD operations, allows you to do queries with gets and inserts with posts and updates with puts and so on, all without having to write a single line of SQL or PL/SQL. It also gives you a good guidance on how to do it using the core REST principles with resource-centric APIs and using standard REST verbs for operations for get and post and that sort of thing. The next thing is query filters. Again, I'm just going to briefly go over it, and I'll be going in much more detail in the demo. But what this allows application developers to do is to submit pretty capable single table queries with predicates and sorts and that sort of thing. So application developers don't need to know SQL, but just using JSON, they can do pretty sophisticated, against this, just single tables. You can't do joins and things like that, but just single table operations. And I'll be going through this exact example and how to set it up and what it looks like when you do a query using a REST client and all that sort of stuff in a minute. The last thing I want to talk about is how to manually create modules and templates and handlers. So basically a module is an application, you can look at it that way. A template is a resource like orders or products or that sort of thing. And a handler is a routine to perform a specific operation like a get or a put or a post or whatever on that resource. So here's an example of setting up a module called RESTful, a template called customer orders, and a handler for a get operation. And what this is going to do is return in a JSON object information about a customer and all their orders. It allows you to use SQL Developer, all the good development tools that it has, including worksheets for defining the SQL and the ability to execute it, to test it out within SQL Developer before you actually deploy it on ORDS. So all that is good stuff. To go in a little more detail of what this is actually doing, this bit of code here is actually doing, in the database I have these tables. I have customer table, orders table, order items table, and then a product lookup table. So the order items might have product codes, and you can look up in the product table to find the name of the product and so on. But what I want to retrieve with this query, with this get operation, is a row for each customer, and for each customer, rows for all their orders, and for each of their orders, all the order items and product information that makes that up. And I want to return it as a hierarchical JSON document. So it will start off by having the customer information I want, which is just the first and last name and the city that they're located in this example. And then each order, and each order contains order item information about the order as itself, and then information about the order items. But it all comes back as a single JSON nested object that can be integrated easily into objects within the programming language. So this gives you an example of how you can do more sophisticated things by manually creating services. So now I'm going to show you a demo of the first capabilities I talked about, the auto enablement and query filters. This is a video that's on YouTube in a series which I call Quick Briefs on ORDS, which I'll be talking about at the very end. So here, let's play the video. This next major area of new capability in Oracle REST Data Services 3.0 release, I think is perhaps the most interesting one and really shows the potential of ORDS. And this is for auto enablement and query filters. So what this does is automatically generates about a dozen basic operations on single tables. So here's a list of the things that it will automatically set up for you in a very simple process flows. There are things like get schema and table metadata, get all rows in a table, basically do a SQL equivalent of a select star, get one row using the primary key, get or post table rows using a query filter, which I'm showing you examples of and drilling into in a little more detail in the next slide. And then do an insert, do a bulk insert, do an upsert, do a delete. So this functionality is provided by SQL Developer 4.1. There's also a PL/SQL API that drives this. So the other part of this is a query filters. And let me show you how that works, give you a flavor for it. I'm not going to try to go into all the details, but give you a good flavor for it. So it allows you to specify predicates and sorts in JSON. So we're not using SQL here. We're using JSON, which is something that many new developers are very comfortable with using and very easy for them to adopt. It follows a kind of a query by example kind of format. Key thing to know is it only works on single tables, not multi-tables yet. But it does basic things and quite powerful things. So it works with date, number, string data types, about a half dozen operations for each one, and does basic Boolean and or operations. So I have an example here, a fairly sophisticated example. Again, it is a query by example kind of format. So we're going to be doing a query on the IMP table, and one of the fields in the IMP table is salary. And so we're going to be looking for those employees whose salary is between 1,000 and 3,000. We're also going to be looking for employees who have a hire date that is less than or equal to this date, which is April 23rd, 1981. And we're going to use an AND condition, so both these things have to be true to select an employee. And then when we get those results, we're going to do an order by, in ascending order by the employee name. So that's basically what it's about. Now let's go and do an example of that. So I'm going to pull up SQL Developer 4.1. I have a connection to the PDB Connect database, which I've been using. And here is the schema I'll be working with, which is Scott. So I'm going to connect to that. And the first thing I need to enable the schema. So what you do is you right-click on the schema and select down at the bottom. It says REST Services, Enable REST Services. So I'm going to select that. And then there's a very simple process flow. Basically says I want to enable the schema. I'm not going to set authorization of the security yet, just keep things simple. And click Next, and then I'm done. So I'm basically going to click Finish, and it's going to process that command to enable the schema. So this hasn't set up anything yet. It just enabled the schema to be used for auto enablement. So what I need to do is select auto enablement for a particular object. And I'm going to use the IMP table for that. So again, I'm right-clicking on the IMP table and going down to where it says Enable REST Services. And you have a similar process flow where I need to click Enable Object. I'm not going to set up the security. I'm not going to click Authorization Required for this simple case, but it just set up enablement. And that's it. Again, I click Finish, and it gets processed. So now for the IMP table, all those operations I showed you before now are generated and enabled, ready to go. So to demo that, I'm going to pull up a REST client. And the one I'm using is called an advanced REST client. There's a number of them. You just Google REST client, you find all sorts of ones that are available. They're all basically do the same thing. They're all pretty good. So what a REST client allows you to do is specify a URI. So you can see we have a URI that points to the IMP table. It connects to localhost, the port I've set up ORDS on, and the Scott schema and IMP and so on. And I'm going to be doing a GET. And when you just specify the resource and just specify that the request is a GET, that basically means I want to do a select star. I want to select all the rows. So I'll send that GET now off through ORDS to be processed, and I get the result. So you know that things worked right when you get this 200 OK status response. And then you can see in JSON the results of doing the select star from IMP. And it's about 14 rows, and you can see each one contains the employee number and the name, the job, and so on. So that's the first thing I want to show you. This next thing I want to show you is a query filter. So for that, I'm going to need to do a post operation. So I have that already set up, tested before, so I just pull that from my history. Note that the URI is still the same. It's exactly the same resource. It's the IMP table. But instead of doing a GET, I'm now doing a POST. So a POST is a particularly powerful request in that I can specify data in the body of the request, or what is sometimes called the payload of the request. And here is that JSON predicate and sort request that we went through before. Salary between 1,000 and 3,000, hire date less than or equal to April 23rd, 1981. It's an AND condition, and I want to do an order by, an ascending order by employee name. So you specify that in the body or payload. The other important thing is the content type. So this particular content type specifies that I want to do a query with a query filter. If I set a different content type, it may mean I want to do an insert of this JSON object into the table. So that's the third important thing. So it's the URI, it's the request, it's the body, and then the content type, or actually 4 things rather than 3 things. So I send that off. And the result I get shows that it worked, status 200 OK. And now I can see that I have the results that satisfy that predicate. So the salary is between 1,000 and 3,000. The start date is before April, less than or before or equal to April, was it 23rd, 1981. And I think I get 3 rows that satisfy that predicate and sort. And that basically is how the auto enablement and the query filters work. Okay, so to get more information, the places I recommend are the following. First, on the Oracle website, on the Oracle Technology Network, there are web pages on ORDS. You can see a screenshot of that web page. Contains information about basic overview information on ORDS. Gives you information on how to download ORDS. ORDS is downloaded separately from the database, which is a nice thing, and that allows us to produce a lot more releases of the product and introduce functionality more quickly than waiting for releases of the database. We release independently of the database. You can also find all the documentation that's available for ORDS. the community web pages, which shows all the blogs that a number of us who are involved in ORDS do. So my blog is there, and other blogs for some of the senior developers are also available there. And lastly, there's a section on Learn More, which contains pointers to a number of YouTube videos, which are a series I'm calling Quick Briefs on ORDS 3.0, which is the latest release of ORDS. Each one of these is a short video, less than 10 minutes. I think most of them are like 7 or 8 minutes long. I already showed you the auto enablement and query filter one, but we have another one on installation, another one on OAuth 2 security, another one on multiple data store support, so you can see how ORDS can be used not just with the Oracle Relational Database, but JSON document store within the Oracle database, and also the Oracle NoSQL database as well. So hopefully that was useful for you, and hopefully this gives you pointers of where you can go to continue to learn more about ORDS and use your ORDS and get a lot of benefit from it. Okay, thanks.